Every robot starts with proportion, height, reach, and balance drawn into a plan. The sketch becomes geometry, a digital skeleton that defines how it will move. In simulation, thousands of steps teach balance before metal ever moves. Prototype parts confirm size, weight, and range before real metal is cut. Precision machining turns design files into load-bearing joints. Actuators provide force, sensors report position, movement the controller can trust. Power flows through the limb, the first controlled motion of our robot. The robot stands for the first time, design becomes a body. Cables link every joint and sensor, turning structure into a living circuit. A processor becomes its mind, ready to calculate, sense, and learn. Power surges through steel, the first heartbeat of our creation. It learns from our hands, copying motion until precision feels natural. Balance, motion, and code unite. The robot walks on its own. Each repetition refines control. Every movement becomes smoother, smarter. Every joint is pushed to failure limits so the final robot never reaches them in use. Robots must fall safely, learning how to stand again without harm. Temperature control keeps motors alive. Cooling equals endurance. Soft polymer shells absorb impact, protecting people and parts alike. Vision is tuned until every millimeter in the world is measured right. Safety means empathy. The robot must feel pressure and step back. Endurance proves trust, thousands of cycles before a single customer ever meets it. Final diagnostics complete, ready to leave the lab. Packed with precision, the journey to its first home begins. The future steps into everyday life, quietly. Designed to help, not replace, it handles the routine with care. When machines cooperate, human effort multiplies. When tasks end, it finds its own rest, charging for tomorrow. Each machine we build teaches us something about ourselves. The future has already begun.